You're going to start in the purple homework packet. And instead of working through a couple problems at a time like we did yesterday, I want you to go through and state the LCD for all 6 of these problems on page 3 first. So for tonight, you should be able to work on numbers 13 through 24. And this assignment, pages 3 and 4, that will be due on Wednesday. Tomorrow night. So, but this is all we're doing the rest of class is working on these problems. So, folks, let's do the LCD for the first 2 problems together, and then we'll check in on some of the other ones. So, folks, I look at the denominators of the first one. I see that minus sign, so I'm instantly going to float that up with the 4. And if you're like, Miss Cairo, it doesn't make a difference. I know that that negative goes with the fraction. You are a lot less likely to forget about it if you explicitly put it up with the numerator. So that's the first thing that I would do on that problem. Looking at those denominators, knowing that these are monomials, what's the greatest amount of 3's that we have in one fraction? 1, 3. What's the greatest amount of x's we have in one fraction? 1x. So, boom, LCD is 3x. Folks, this is required work on the homework. It's going to be required work on the test as well. So, stating the LCD first. Folks, on number 14, a lot of times students tell me that the LCD is, so we're going to write this with an angry face by it. A lot of times students tell me that the LCD is x plus 2. And if you're like, I thought it was x plus 2, we're going to talk about the problem of why x plus 2 doesn't work. So if I asked you to make x look like x plus 2 using a creative form of 1, can we just add 2 to the top and add 2 to the bottom? No. You're like, I don't know, it seems like we could. Let's go back to that easy fraction of 1/2. If I add 2 to the top and add 2 to the bottom, we get 3/4. Can I add 1 as a creative form of 1? No. We can only multiply by creative forms of 1. So this is not valid because it changes the value of 1/2 to 3/4. So I can only get these fractions to get to the LCD by multiplying them together. So this is no good. So what I would do to avoid this mistake, trap that x plus 2 in parentheses. It is its own factor. So I've got a monomial and a binomial. What's the greatest amount of x's that we have? 1x. What's the greatest amount of x plus 2's we have? 1x plus 2. So both of those are part of our LCD for that one. I would put a star by that one. It's a tricky one. And there's some others like that as well. All right, folks, couple of minutes to try to find the LCD for the next 2. Minus signs all over the place. go ahead and check yourself on the first one. So on that first denominator, we can take out a GCF of 3. Then the second denominator, that's difference of squares. So x plus 2 and x minus 2. So monomials first, the greatest amount of 3's that we have in one denominator is 3. The greatest amount of x plus 2's that we have in one denominator is 1 x plus 2. And the greatest amount of x minus 2's that we have in one fraction is x minus 2. How did we do on that one? Raise your hand if you got it right. So binomial GCFs, that 3x plus 6, those are tricky. Raise your hand if you're done with the next one already. Okay, I'll give a couple more minutes for people to work. And if you're done with those two, you can move on to the bottom ones. Drew, what did you end up taking for that headache yesterday? What ended up curing your headache yesterday?
I went to sleep.
You saw. Okay, folks, on the next one. Can we factor that first denominator, 4y minus 8? GCF! Same with the second denominator. So if you just use that as part of the LCD and that as part of the LCD, your numbers would get very large and you would have a lot more work and a lot more simplifying to do at the end and a lot of foiling as far as the top goes. So when you factor that, the greatest amount of 2's that we have, once we take out that GCF, we break it down since it's a monomial. The greatest amount of 2's that we have in one term is 2 2's. And for this one, the greatest amount of y minus 2's that we have in one term is 1. So your LCD is 4 and y minus 2. Now if you're like, crud, I had 8 for the LCD, you would get docked points for not being able to find the least common multiple. But folks, you can get to the right answer using any common denominator. If you can make both of those fractions have the same denominator, just like we showed in the notes, this still gave me 3/4 when I went up to the denominator of 8. It was just more work and more simplifying. So if you did have 8 times y minus 2, you could potentially still get to the right final answer. Folks, we're going to sidebar over to the back. And again, I would write down LCD by each of these problems so that you would know you have to state it for all of them. And I'd like you to try 21 and 22, so the middle problems. See if you can find the LCD for both of those. And then we'll start actually going through some of these problems fully. All right, folks, for the first one, binomial denominator, trap, 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 trap. So the greatest amount of z minus 4s that we have in one term is 1z minus 4. Greatest amount of z plus 1s, 1z plus 1. So z minus, that looks awful. Let's try again. Z minus 4 and z plus 1. There's our LCD. And then for this one, so let's see how we did on this trickier one. We factor that denominator as x plus 1 and x plus 1. And then this one is x plus 1. Folks, what's the greatest amount of x plus 1s we have in one term? There's 2. So x plus 1 times x plus 1, or x plus 1 squared, would be your common denominator. Boom. All right, folks, so we're going to go ahead and start going through some of these all the way to the end. Let's go ahead and go back to 21 for a moment. So, folks, let's start with our first fraction, and you can choose to write your creative form of 1 work to the side if you don't want to do all that writing. Totally up to you, but I do have to see some work. So we've got 4z over z minus 4. What are we going to use as our creative form of 1? Z plus 1 over z plus 1. Trap, 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 trap. Then we've got z plus 4 over z plus 1. For this fraction, trap, 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 we will need to use z minus 4 as our creative form of 1. It's Kyra, why are you putting the lines on the z's? Because sometimes my z's look like 2's, and this keeps me from thinking they are 2's. So trapping all those binomials in parentheses. Now remember, once we have used those creative forms of 1, we are going to distribute on the top and slide the denominators together. So 4z times z is 4z squared. 4z times 1 is 4z. And then all over z minus 4, z plus 1. So how am I going to distribute on the top with the second fraction? What are we going to have to do? We're going to have to FOIL. So z times z, first times first, z squared. O part of FOIL, outside terms, negative 4z. Inside terms, positive 4z. And last terms, negative 16. All right, folks, from here, do we have any like terms or any simplifying that we can do? Yep, goodbye to negative 4z and positive 4z. Folks, if I have 4z squared plus a z squared, how many z squareds is that? 5z squared. And then we have plus 4z minus 16. All over z minus 4, z plus 1. Why should I not put a box around my answer yet? We should try to factor the top and potentially simplify. So let's give it a shot. I'm just going to sidebar over here so I can show my X method work. So 1z and 5z. And then 16. Oh no. How many factors are there of 16? A lot. So let's try 1 and 16 first. So luckily we only have 1 and 5 for factors of 5. Let's try 1 and 16. So 16z and 5z. Is that good? No, it's not good to get 4. So then we switch. 16 times 1. Ooh, 80z and 1z. That's not going to be good either. So let's try 2 and 8. That gives me 8z. That gives me 10z. Closer. Still not good. 8 and 2. 2z. And 40z. Ooh. Definitely not going to get me to 4z. So I'm getting annoyed, but I still have to try everything just in case I miss something. So let's try 4 and 4. We get 4z and 20z. So what does this mean? It's prime, so we can't factor it. So trap that sucker in parentheses. That's as simplified as our answer is going to go. Boo. An annoying amount of work to show, but we always have to check to see if we can simplify all the way. Let's go ahead and flip back to the front. I think I'm going to turn you loose on 13 and 14. And we'll start doing catch and release on this problems, and I'll start putting up the answers, and you guys can ask questions as you start working on them. So start with 13 and 14.